Hi everyone, this is me Sonia Geo, a faculty at Silver Hills Public School. Here I am going to discuss about the chapter Electricity of Class 10 CBSE. Electricity is probably the eighth wonder of the modern civilized world. Its discovery and utility have revolutionized the homes and industries of the civilized world. Life today is totally dependent on it. You know the importance of electricity. We cannot imagine a day without electricity. We can say electricity is one of the important phenomena in our day-to-day life. In this section, we shall study the basic concepts of electricity, electric current, circuit symbols, electric circuit, voltage or electric potential, resistance, resistivity, Ohm's law, resistors in series and resistors in parallel. The flow of electric charge is known as electric current. Electric current is carried by moving electrons through a conductor. You know the movement of electrons. Electrons are moving from negative to positive. So the current flow will be to the opposite direction of electrons. That means the current will flow from positive terminal to negative terminal. Electric circuit. Electric circuit is a continuous and closed path of electric current. Here you can see a simple circuit. So the circuit is having one key, a cell and a bulb. You can see that if you are connecting this bulb to a cell and a key, the bulb will glow. That means the current will flow from one point to another. Okay. Then expression for electric current. Electric current is denoted by the letter I, and electric current is expressed by the rate of flow of electric charges. Rate of flow means the amount of charge flowing through a particular area in unit time. That means if Q be the quantity of charge and T be the time, then we can say that the current I is equal to Q by T, where I is the electric current, Q is a net charge and T is a time in second. So this is the equation for electric current, I is equal to Q by T. Then the SI unit of electric charge and current. The SI unit of electric charge is coulomb. It is represented by the letter C, and the SI unit of electric current is ampere, is represented by the letter A, capital A. We can define 1 ampere of current. 1 coulomb is nearly equal to 6.25 into 10 raised to 18 electrons. If 1 coulomb of electric charge flows through a cross section for 1 second, it would be equal to 1 ampere. That means you know the equation for electric current, I is equal to Q by T. I is equal to Q by T, and the unit of current is ampere, unit of charge is coulomb and unit of time is seconds. So we can say if it is 1 ampere, the charge is 1 coulomb and the time is 1 second. 1 ampere of current. If 1 coulomb of electric charge flows through a cross section for 1 second, it would be equal to 1 ampere, or 1 ampere is equal to 1 coulomb divided by 1 second. Small quantity of electric current. I told you that the unit of current is ampere. Suppose for the smaller quantities, we can say the one of the unit is milliampere and the other one is microampere. For the case of length, usually we used meter. Maybe for smaller units, we may use centimeter, millimeter, like that. Same way, current also we can express in terms of milliampere, microampere. 1 milliampere is equal to 10 raised to minus 3 ampere. and 1 microampere is equal to 10 raised to minus 6 ampere. For the numerical section and all know, if it is in terms of milliampere or it in microampere, you have to convert that into ampere. Then the device used to measure electric current is ammeter. See, this is the ammeter. Okay, you can see the readings from 0 to 100. Okay, this is ammeter and this one is milliammeter. Okay, milliammeter, and it has two knobs. One is negative, other one is positive. So according to the connection, connect this ammeter properly. Remember one thing, ammeter always should be in series. If you are connecting ammeter in a circuit, it should be connected in series. 1 coulomb of charge. You have studied the expression for current I is equal to Q by T. From this equation we can write Q is equal to current I into T. Suppose if it is 1 coulomb, then we want to say that the current is 1 ampere into time 1 second. So 1 coulomb is equal to 1 ampere into 1 second. Thus the quantity of charge which flows through a circuit when 1 ampere of current flows through it in 1 second is known as 1 coulomb charge. Next topic is electric potential. The electric potential energy per unit charge is called electric potential. Potential difference. Electric potential difference between 2 points A and B on a conductor through which a current is flowing is defined as the amount of work done to move a unit charge from A to B. So we can say that the potential difference V is equal to W divided by Q, where V is the potential difference or voltage and W is the work done and Q be the quantity of charge. I repeat, electric potential difference is known as voltage, which is equal to the amount of work done to move the unit charge between 2 points against static electric field. Therefore, we can say voltage is equal to work done divided by charge. Then the potential difference, the equation is V is equal to W divided by Q, and W is the work done, Q be the quantity of charge. We can define 1 volt. You know the equation V is equal to W divided by Q, where W is the work done and Q be the quantity of charge. If you want to write it as 1 volt, then we can say that the work done, it should be 1 joule. The unit of work done is joule and unit of charge is coulomb. So we can say 1 volt is equal to 1 joule divided by 1 coulomb. That means 1 volt is equal to 1 joule by 1 coulomb. 1 volt of electric potential difference is equal to 1 joule of work to be done to move a charge of 1 coulomb from one point to another in an electric circuit. 1 volt is equal to 1 joule divided by 1 coulomb. The device used to measure potential difference is voltmeter. We have studied that the device used for measuring current is ammeter. Similarly, the device used for measuring potential difference is voltmeter. Here you can see one voltmeter. The range of voltmeter is from 0 to 5 volt. Okay, 0 to 5 volt. And remember, this voltmeter always should be in parallel. If you are connecting voltmeter in a circuit, it should be in parallel. Another device, galvanometer. This galvanometer is used to detect the presence of current in the circuit. We cannot measure any current by using this galvanometer. The use of galvanometer is that to detect the presence of current in the circuit. This is galvanometer. Next topic is factors on which the resistance of a conductor depends. There are many factors. First one, the resistance of a conductor depends on nature of the material, length of the conductor and area of cross section. By using all these factors, length, area and all, we can derive the expression for resistivity. Length of a conductor. The resistance is directly proportional to length of the conductor. That means if you are increasing the length of the conductor, the resistance of the conductor will be more. That means resistance is directly proportional to length of the conductor. That means the resistance increases with increasing length of the conductor. This is the cause that long electric wires create more resistance to the electric current. Next one, area of cross section. The resistance is inversely proportional to area of cross section. If area is more, resistance will be less. The resistance R is inversely proportional to the area of cross section of the conductor. This means that R will decrease with an increasing area of conductor and vice versa. More area of the conductor facilitates the flow of electric current through more area and thus decreases the resistance. This is the cause that the thick copper wire creates less resistance to the electric current. We can say resistance R is directly proportional to 1 by A, or we can say resistance is inversely proportional to the area of the conductor. We can derive the expression for resistivity. You know the factors effects on resistance are length of the conductor and area of cross section. We can say R is directly proportional to length of the conductor. Put as equation number 1. Next relation, R is directly proportional to 1 by area of cross section. 1 by A, put as equation number 2. Combine equations 1 and 2. We can write R is directly proportional to length L divided by area of cross section. Next up, we want to change this directly proportionality sign into equal sign. We can write this equal sign by multiplying by a constant. Here that constant is rho, and this rho is called resistivity of the material. We can write resistance R is equal to rho into L by A, and this is the expression for resistance. R is equal to rho L by A. From this equation, we can write the expression for resistivity. For that, cross multiplying, we can write resistivity rho is equal to RA divided by L, and this is the final equation. Resistivity rho is equal to RA by L, where R is the resistance, A be the area of cross section and L be the length of the conductor. Rho is the proportionality constant. It is called the electrical resistivity of the material of the conductor. Then we want to study about the SI unit of resistivity. For writing the SI unit of any physical quantities, first of all we want to write down the proper equation. You know the equation rho is equal to RA by L. Resistivity rho is equal to RA divided by L. For writing the unit of resistivity, first of all we want to take down the unit of resistance. The unit of resistance is ohm, OHM, or you can use the simple ohm. Then the A means area of cross section. The unit of area is meter square divided by unit of length is meter. We can cancel 1 m. So we can write the unit of resistivity is ohm meter. This is the simple ohm meter. So this is the expression for resistivity ohm meter. The SI unit of resistivity is ohm meter. Resistivity is defined as the electrical resistance of a conductor of unit cross-sectional area and unit length. You know, if rho is equal to RA by L, if area is equal to 1 meter square, we can write if area is equal to 1 meter square and length is equal to 1 meter, then we can write rho is equal to R. So, we can define resistivity. It is defined as the electrical resistance of a conductor of unit cross-sectional area and unit length. If area is 1 meter square and length is 1 meter, we can say that resistivity rho is equal to resistance R. Next topic, circuit symbols. First one, an electric cell. This is the representation of a cell. You can see that there are two terminals, one is smaller one and other one is longer one. Longer one represents positive. Second one, battery. Battery is a combination of cells. This is the representation of battery. Here two cells are used. Next one, switch or key. First one, this is closed key and this is open key. You know, if the key is closed, current will flow through the circuit. And here if the switch is off or when the key is open, we will say there is a gap between the terminals. Current will not flow from one point to another. So, this is a representation of joint wire. Electric bulb, the representation of electric bulb is this one. Suppose if the bulb is glowing, you can show this way. So, this is the representation of electric bulb. If it is connected to a battery and a key, the bulb will glow. Resistor, the representation of resistor is this like. It is used to restrict the amount of current flow in the circuit. Variable resistor. This is the representation of variable resistor. The use of variable resistor is that we can adjust the value of resistance. We don't want to connect one by one. By using this rheostat, we can regulate the amount of current flow by increasing or decreasing the resistance to the current flow. Ammeter. You know, the ammeter is used for measuring electric current. The representation of ammeter is this way. And this having terminals positive and negative. Properly you want to connect this ammeter in the circuit. This is the representation of voltmeter. It is used to measure the voltage between 2 points in a circuit. So, these are the symbols which we have studied. Next one, we are moving to the one of the important topic in electricity, that is Ohm's law. This is a scientist named Geo Simon Ohm. He introduced this law, Ohm's law. According to Ohm's law, at constant temperature, current through a conductor is directly proportional to the potential difference applied across its ends. Remember, the temperature remains constant. We can verify Ohm's law by using one circuit. For doing that activity, we need all these apparatus: resistor, ammeter, voltmeter, battery, key, rheostat, etc. This is a circuit diagram of Ohm's law. I will explain about this circuit diagram. Here you can see this is a battery. There are 3 cells used. This is a battery. And this positive wire, from the positive wire which is connected to the resistor one end, and the resistor other end is connected to positive of the ammeter. Then ammeter negative side is connected to key, key's other end is connected to the rheostat other end. Then this voltmeter should be in parallel. That's why across this resistor voltmeter should be connected. And this ammeter should be in series. Then the flow of current, you know, the current will flow from positive terminal to negative terminal. We can show the arrow mark like this. Current will flow from positive terminal to negative terminal. Here the positive current is flowing, that is why the voltmeter here this is plus and other side which is negative. Then again the positive current is flowing, so ammeter this is plus minus. For doing this circuit, initially the key is closed. When the key is closed, current will flow from one point to another and the rheostat is adjusted to get the minimum reading in ammeter A and voltmeter V. The current in the circuit is increased gradually by moving the sliding terminal of the rheostat. During the process, the current flowing in the circuit and the corresponding value of potential difference across the resistance wire are recorded. This way, different sets of values of voltage and current are obtained. Initially, the key is closed. Adjust this rheostat. Then we can see some readings on this voltmeter and ammeter. Note down the reading voltmeter and ammeter. Second time again adjust this rheostat. Note down the reading of voltmeter and ammeter. Repeat the same steps and you may record all these values in the observation table. For example, we can write V, I and R. From the voltmeter and ammeter, we can measure the readings and we can write that values here. For example, if voltage is 1 volt and current is same 1 ampere, and second case suppose if it is 2 volt, here it is 2 ampere, 3 volt, 3 ampere. Then we can find out the value of resistance R. I told you according to Ohm's law, at constant temperature, current through a conductor is directly proportional to potential difference. So we can write V is directly proportional to I or V is equal to I into R, where R is the proportionality constant. You know R is the resistance. Here this is one of the equation for Ohm's law. V is equal to IR, or we can write I is equal to V by R or R is equal to V by I. These are the three mathematical forms of Ohm's law. It comes from the equation V directly proportional to I, where V is the potential difference and I is the current. We can write V is equal to IR. Here we can calculate the value of R by using this equation V by I. R is equal to V by I. The unit of potential difference is volt, unit of current is ampere and the unit of resistance is ohm. So what is the first reading? 1 volt 1 ampere. R is equal to V by I. 1 by 1 we can write 1 ohm. 2 divided by 2 1 ohm and 3 divided by 3 1 ohm. This way we can complete this observation table. After getting this observation table, we want to draw the graph VI graph, voltage current graph. If you are drawing this VI graph, you can see that it is a straight line. So this again proves that the voltage is directly proportional to current. The mathematical relation, there is one small technique. Here see one triangle VIR. Suppose if you want to write the first equation V is equal to IR, just take down V. V is equal to I into R, first equation. Second one, I is equal to V by R. If you are taking this I is equal to V divided by R. Third one R is equal to V divided by I. There are three forms: V equal to IR, I is equal to V by R, and R is equal to V by I. What are the applications of Ohm's law? To determine the voltage, resistance or current of an electric circuit. If you know current and voltage, you can find out the value of resistance. Second one, it is used to maintain the desired voltage drop across the electronic components. Third one, Ohm's law is also used in DC ammeter and other DC shunts to divert the current. Limitations of Ohm's law. Following are the limitations of Ohm's law. Ohm's law is not applicable for unilateral electrical elements like diodes and transistors, as they allow the current to flow through in one direction only. Second one, for nonlinear electric elements with parameters like capacitance, resistance, etc., the voltage and current won't be constant with respect to time, making it difficult to use Ohm's law. You know, according to Ohm's law, at constant temperature, potential difference is directly proportional to current. So, we cannot use that it in case of capacitance, diodes, etc. We can conclude this Ohm's law. After getting this graph, we can see that it's a straight line. What is the meaning of that? It is saying voltage is directly proportional to current. And other thing is that, you know, all the values of resistance are same. 1 ohm, 1 ohm, 1 ohm. Again, which verified Ohm's law. The value of resistance is same for all observations. For all the three readings, the R value is the same and constant. The ratio of potential difference V and current I is the resistance of a resistor. You know, R is equal to V divided by I. With the help of the graph between V and I, Ohm's law is verified as the plot is a straight line. That's about Ohm's law. Then second circuit is resistors in series. Resistors in series means when resistors are joined from one end to end, it is called in series. For example, if three resistors are in series, you can connect or you can draw this way. There are three resistors R1, R2 and R3 are connected in series. The wires are joined from end to end. It is called in series. This is a circuit diagram. There are three resistors R1, R2 and R3 are connected in series. Here one ammeter is there which is connected to a battery, a key, then one voltmeter is connected across these three resistors. Here the current, the flow of current, it is from positive to negative. This is positive, so the current flow will from plus to minus, and this plus current is flowing. Look at the picture. This is battery and this longer one represents positive terminal. This is plus, so the positive current is flowing. So this voltmeter, this one plus, if one side it is plus means the other one is negative. So again that shows this like. This voltmeter is connected parallel to these three resistors R1, R2 and R3. Then let V1 be the voltage across R1 and V2 be the voltage across R2 and V3 be the voltage across R3. Let I be the current flowing through the circuit. Then we can say that here the voltage V is equal to, the total voltage V is equal to V1 plus V2 plus V3, where V1 is the voltage across R1, V2 be the voltage across R2 and V3 be the voltage across R3. The total voltage V is equal to V1 plus V2 plus V3. Resistors in series, we can derive the expression. I told you V is equal to V1 plus V2 plus V3. By using Ohm's law, you know V is equal to IR. Then in the circuit, the current I remains same. Only change in the resistors R1, R2 and R3. So we can write V1 equal to IR1, current remains same, and V2 is equal to IR2. Similarly, V3 is equal to IR3. V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR3. V3 is equal to IR3. Substitute all these values in equation number 1. We can write V is equal to IR. That means IR is equal to V1 is IR1. We can write IR1 plus IR2 plus IR3. Next up, this I is the common term. Taking outside, we can write I into R1 plus R2 plus R3. Then we can cancel this current I. The remaining term R is equal to R1 plus R2 plus R3. This is the final expression. When three resistors are connected in series, we can say the total resistance is resistors Rs represents the total resistors in series. The total resistance is sum of the individual resistances. Rs is equal to R1 plus R2 plus R3. When a number of resistances are connected in series, the resultant resistance is equal to the sum of the individual resistances. If n resistors are connected in series, then you know the total resistance Rs is equal to R plus etc. plus n times. That means that is equal to NR. Next one, resistors in parallel. When resistors are joined in parallel, the reciprocal of the total resistance of the system is equal to the sum of reciprocal of the resistance of the resistors. That means if three resistors are connected in parallel, just we can show the parallel connection this way. Here three resistors are connected in parallel. Three resistors are connected in parallel. Then we can say 1 by Rp represent the total resistance in parallel. 1 by Rp is equal to 1 by R1, this is R1 and this is R2 and this is R3. 1 by R1 plus 1 by R2 plus 1 by R3. This is the result. We are going to prove this one. Here you can see three resistors are connected in parallel, which is connected to a battery, key, ammeter, etc. This is a circuit diagram. Consider there are three resistors R1, R2 and R3 are connected in parallel, which is connected to a cell. Let I be the current flowing through the circuit. From this junction, the current I is divided into I1, I2 and I3. Let I1 be the current passing through R1 and I2 be the current passing through R2, I3 be the current passing through R3. And we can say the total current I is equal to I1 plus I2 plus I3. This is a circuit diagram. We can say I is equal to I1 plus I2 plus I3, where I1 be the current passing through R1, I2 be the current passing through R2 and I3 be the current passing through R3. Proof. The total current I is equal to I1 plus I2 plus I3. By using Ohm's law, you know the equation I is equal to V divided by R. I1 is equal to V divided by R1. In this circuit, the voltage remains constant. There is no change in case of voltage. V remains constant in case of resistors in parallel. I2 is equal to V divided by R2 and I3 is equal to V divided by R3. Substitute all these values in equation number 2. We can write V by R is equal to I1 is V by R1, V by R1 plus I2 is V by R2, V by R2 plus and I3 is V by R3. Here the term V is common. We can write V by R is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. V cancelled. Finally, we can write 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is our result. When 3 resistors are connected in parallel, the relation is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Suppose if 2 resistors are connected in parallel, we can write the relation 1 by R is equal to 1 by R1 plus 1 by R2. When a number of resistances are connected in parallel, the reciprocal of the equivalent, that is the resultant resistance, is equal to the sum of the reciprocals of the individual resistances and is smaller than any individual resistance. We can say if 3 resistors are connected in parallel, the relation is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Today's section we have studied basic concepts of electricity, Ohm's law, resistors in series, resistors in parallel, etc. That's about today's section. Thank you everyone. Thank you all.